Alright, so let's wrap this up. Last problem we'll do. Again, this one's kind of loaded because we don't want all of them. So we're going to have to really use not all of our trig identities, but quite a few of them. So let's start with what we know, right? We know that secant of theta is equal to 2, and we know that we're in quad 4. Alright, and so that makes sense. Secant is positive in that quadrant. But what we also know is that the cosine of theta, or excuse me, alpha, is 1 over secant of alpha. So that must mean, right, that cosine is equal to 1/2. So using my reciprocal identities, I've got one of them. So there's 6 of them. One was given, right, and we actually have a second one. So 4 more to go, right? So how do I find that fourth one? Well, again, I actually think that's probably the best one to go to. The good old cosine squared theta plus sine squared theta equals 1. Because once I have sine, I've got my quotient identities, I've got more reciprocal identities, I've got all kinds of things going on. So finding sine might be the next best thing to do. So we do what we did earlier. We know that cosine squared is 1/2. So when I plug that in, 1/2 squared plus sine squared equals 1. This is 1/4 plus sine squared theta equals 1. Which, if we subtract 1/4 from both sides and write that as 4 over 4, my sine squared theta is basically 3/4. Okay, hopefully this looks a little familiar. Taking a square root, we get that the sine of theta, or actually this is alpha, right? So the sine of alpha is equal to plus or minus the square root of 3 over 2. Now we have to go to which quadrant am I in? Well, in quadrant 4, y is less than 0. Right, so that means that the sine of alpha is negative square roots of 3 over 2. So there we go. So let me kind of record that for prosperity. Using my identities, we now have 3, right? One was given, we found the other 2. And then by default, right, we know that the cosecant of alpha is 1 over sine of alpha. It's the reciprocal. So we have that. And rationalizing the denominator, you get negative 2 square roots of 3 all over 3. So the cosecant of alpha is negative 2 square roots of 3 over 3. So there we go. So we have 4 of them down, 2 more to go. So which one do you want to find? Well, how about we start with tangent, right? Which identity we want to use? We could use a lot, right? Because I know a secant, we can use the Pythagorean, 1 plus tangent squared equals secant squared. Because I know the cosecant, I can use that Pythagorean identity. Lots of things I can use, but how about we just use the good old quotient identity, right? Tangent is sine over cosine. So my sine, right, is negative square root of 3 over 2. My cosine is 1/2. When I divide fractions, I multiply by reciprocal. And what we end up finding is that the tangent, I keep calling it theta, the tangent of alpha is negative square roots of 3. So there you have it. So one more left, right? What's missing is cotangent. Well, what do we know about cotangent? It's the reciprocal of the tangent. So this becomes 1 over negative square roots of 3. Rationalizing my denominator, we get negative square roots of 3 over 3. So the cotangent of alpha is negative square roots of 3 over 3. And there you have it. If you go back and you look at the very first video when we were using XYR definitions, we got the same exact values, but this time we approached it by using my identities. It looks like I used 1, 2, 3, 4, 5 different identities to get where I want. And that's the kind of skill it's going to take, because I promise you, as we move forward, we're going to be proving identities, we're going to be solving equations, right? And the better you are at kind of seeing and pulling out an identity to work with, the better you're going to be at trig later in your game. So even though I would totally agree with you, the XYR definition is like, well, why don't I just use that? That's so much easier, right? You have to get good, you have to be able to perform pulling out trig identities, working with trig identities, seeing the trig identities, making the trig identities work for you. And the only way you get better at that is by using them. So please make sure as you do 1.4 homework, right? Are they asking you to use an XYR definition? Go for it. Are they asking you to use an identity? Please use the identities. Same thing on the quizzes. Deal? So that wraps up 1.4. So as a matter of fact, I think that wraps up chapter 4. We got our definition and we built a lot of good math around it, started to investigate our functions, their domains, their ranges, where they're positive, where they're negative, finding values. We did a whole bunch of great stuff with it. Much more to come. If you guys have questions, please ask. Go on Canvas, ask the question about a video. If I made a mistake, call me out, which has already been done. And then also, post it on Canvas, post your questions, do your homework, ask for a virtual office hour if needed, right? We can do this, you guys can do this, let's all work together. See you guys in some more videos coming up.